We will be talking about the guidelines for dimensioning for the entire rest of the term, and we will just get more and more professional and more refined. And you might recall that we have various ASME standards we follow. Here's the big one, ASME Y14.5. This is the dimensioning standard, or to be precise, dimensioning and tolerancing standard. This is the one we follow. And we say so in the title block of our drawing. Our drawing adheres to ASME Y14.5, the 2018 version, which is the most recent version. This ASME standard has been going for a while, starting in 1966, and every so many years it gets revised again. We're on version 2018 now, and this is its full name. This is the name that we write in our title block, ASME Y14.5-2018. Okay, so on to dimensioning. In your role as a communicator with your whoever it is in the shop that's going to be making your part, you need to give them everything they need to know to make the part. They need to know what material is it, what shape is it, and what size and location is every feature. How do you do that? For the material, you usually give them a bill of material. And in our drawings, can I back up and see this here? Yeah. This is the lower corner of our drawing title block for our class. Here, stuck onto the title block, is our bill of material. So this is where we are writing what material our part is made out of. And for some of our class drawings, we'll pay attention to this, and I think there are a couple where we just ignore it. In the real world, though, we don't ignore it. We must tell them what the thing is made of. There are some drawings where instead of a bill of material, you might put a note. Maybe you're making a casting and you're telling them what grade of cast iron goes in there or something. All right, okay. How do you tell them the shape? You draw it. You show them the geometry. How do you tell them the size and location? With dimensions. So for this wedge-shaped part with a round corner, it's got a hole in it, and you put a diameter dimension to tell them the size of the hole, and these two dimensions to tell them the location of that hole. And then in this top view, we can see that the hole goes all the way through. So how do you figure out what dimensions to put on and where to put them? We need to have, for every feature, we need to have its location and its size. And a feature could be a hole, or an angle, or a thickness, or anything on this part is a feature. So every feature needs to be located and sized. And we must do that in all three directions. So the location and the size in the X direction, the Y direction, and the Z direction. It turns out that for most features, you don't need to get too crazy with the dimensions. For example, let's think about this hole, block with a hole, the drafter's classic part. So this block with a hole, here's a size dimension for the diameter of the hole. Here are locating dimensions for the hole center line. And for the depth of the hole in the Z direction, we don't need to give them a dimension because our top view of our drawing shows, with hidden lines, that that hole goes all the way through. Okay, that's well and good, but how do you figure out what dimensions to put on And even more, how do you figure out when you're done? This is something that honestly just takes a lot of practice doing it over and over again. You get so you will notice, hey, that one is missing, or hey, that looks pretty good. But here's a methodical way to go through it step by step. Let's say you're trying to dimension this L-shaped part shown at the bottom. It's got a radius nose and a hole and a notch and stuff. The step-by-step way to tackle this is to look at that thing and think about what simple geometric shapes could you find in there. So now going to the top of the page, that bottom leg, that's just a flat slab with a rounded nose on it. So you could think about, okay, how am I going to dimension that? Well, I need to give a thickness. Okay, there's the thickness. I need to give the center of that radius, so there's the center, and I need to give the size of that radius. There's the radius. You'll notice that these are apparently metric dimensions. Okay, so now you have adequately dimensioned this entire part. Now, you might be thinking, wait a minute, nobody dimensioned the width. Yes, they did, because here is the center line of that radius, and here is the size of that radius, and if it's 15 millimeters up, it's also 15 millimeters down. That's the width of that thing is going to be 30 millimeters. We'll learn about that when we learn about rules for dimensioning diameters and radii. So there's that. Okay. Now picture sticking the next shape on this vertical leg here. And for now, just make it a square leg. Don't worry about the notch. Okay, there's the leg sticking up. What do we need? Well, we need to know how thick that thing is. Okay, there's the 9 millimeter. And we need to know how high it is. There's the 25 millimeter. And in the top view, we can see a little bit more clearly that it goes the full width side to side. Okay, now we got that thing. Now let's tackle that notch. All right, well, it looks like the view where we can see the dimensions of that notch is going to be this side view. So that's where we can go put a width for the start of the notch, a width for the cutout, and the depth of the cutout. Now that thing is fully dimensioned because we already know that it's 30 millimeters across. Finally, we'll think about that hole that gets put in the middle of that ear. And we already have center lines. That's where that hole is located. We just need to tell them the diameter of the hole. And now we have given them every dimension that they need to make that part. Okay. Now, there's no rule that says how far apart you must space these views. The guideline is try for a balance of white space. White space is the area on the paper that does not have ink on it. In graphic design, graphic designers think about white space a lot, and graphic designers actually say white space is an element, just like that L shape is an element, and that round thing is an element. That big empty white space is something to design with too. So as a drafter, we try to look for a balance of white space. Now the front and the side view are not the same distance apart as the front and the top view. You have dimensions in some places and not in other places, so we just try and make it sort of balanced looking. There's no rule. Nobody's going to get mad if it's not quite even. The example on the left here has the views too close together, And how you know that is there's a big old glop of white space around the edges and not much white space in between them. The view of the three parts in the middle has them too far apart, so there's not much white space around the edges and just a big old cavernous vacuum in the middle of the sheet. That's too much. Let's look at the example on the right. That's about right. You have some white space around the edges, some in between the parts. Notice that there happens to be more white space on the right than there does on the left. That's totally fine. Probably they're planning to put something over here, we don't know what. It doesn't have to be exact.